Hi everyone and welcome to another episode. Yes, I am not dead, and I promise you that the gap you've seen in my recent videos is not because I've lost motivation or because I don't want to do YouTube anymore or anything like that. Quite the opposite. I've now built like a backlog of things I want to talk about. So without any further delays, let's start talking about smoothing. Smoothing is everywhere in video game programming, whether it's character movement, animation, camera movement, or just menu UI elements animation. You always have to deal with a different kind of smoothing, and there's many ways to implement smoothing. There's a Bezier curve, ease in, ease out, tweens, and a lot more. And anyone who has done animation or art usually know about these kind of things, but for programmer it can be a little bit tricky to implement in the code. And in my case, I've done at least a dozen different implementation throughout the years of some kind of smoothing on camera systems. And I want to share with you guys the final result after many failed implementation of what I think is probably the best way to implement some kind of camera smoothing as a programmer. Now, all these smoothing methods are basically just a mathematical way of defining the movement of something. So whether it's a UI element or a character movement, you're just trying to describe three things basically: the start point, the end point, and the variation of the speed between those points. So the first thing you want to do when you want to choose a method for smoothing is, of course, look at the libraries that provide you with already made methods for doing this kind of stuff. So there's a lot of tweening and Bezier curve implementation out there, but the problem I found with these things is that they usually expect all the 3 points I've mentioned before to be fixed. So your start position, end position, and the duration of your animation has to be decided ahead of time. And when you're implementing, for example, a camera following a player, then every frame these things are going to be different because the player is going to be moving, which is kind of the end point of your camera, and the camera every frame will be updated, and you have to recalculate all these things, and it can be kind of hard to use pre-made implementation. So that means that the only thing you can do is implement your own system. And the first time I did that, I decided to go with a spring system because I figured what I'm trying to accomplish is basically like a spring. When the player moves, the spring gets tensed and then it pulls the camera, and it kind of smooths everything because every time the character turns around or something, the spring will be stretched and then the camera will accelerate to catch up to the player. And it sounds like a good idea until you realize that even if you implement some kind of damping system to prevent your camera from bouncing back, like a normal spring, you'll always get, maybe because of float imperfection or maybe because of your frame rate, but you'll always get some kind of bouncing. And even the tiniest bits of bouncing can be very jarring when you're looking at the scene and suddenly your camera is going like doing and you don't really know why. So as a clever programmer, I looked it up online and I found a nice suggestion by a lot of people to do this kind of smoothing. Just take the distance you want to cover and cut it by half every frame. Well, it doesn't need to be half, but something like that. So this is really clever because if your target is moving away, then you're gonna keep chasing after it by half every frame. But if it's staying stationary, then by getting closer by half the distance every frame, you're never going to quite reach it, but you're gonna get very, very close. And this will give you a very nice smooth curve of getting closer and then slowing down as you get close to your target. And now I'm here to tell you, don't do this the stupid way unless you're trying to make a prototype quickly and you don't have time to figure out the actual way of doing it. Because by just dividing every frame by a certain factor, you're just making it time dependent. No matter how hard you're trying, you're always going to be dependent on your frame rate. Oh, I can hear you. You're saying, but oh, if I just multiply my fraction by the delta time, I'm going to be all right. No, you won't, because what you're doing is basically butchering an exponential function. And to prove my point, I've taken the time to implement both smoothing method with a real exponential and with this kind of fake interpolated exponential for the camera panning of my game. And let me show you what it looks like. Here you have these two methods. One I've called the fake one and one I've called the real one. And as you can see, they both seem to have about the same complexity, and it's not a very big method. There are just like a couple of lines each. I'll admit that the formula in the second one, the real version, is maybe a little bit more complicated to understand, but in general they have the same complexity. Yes, I know people will say, but you've got a log and an exponential, this is so expensive, you're much better off with just a division or a multiplication. That might be true, but seriously, guy, how many camera do you have in your scene? If you're doing this smoothing for your camera, it's once per frame, it's never going to matter. And even if you're doing it for like UI elements, unless you have like 10,000 UI elements being animated at the same time using this method, I can't even begin to imagine these exponential taking any amount of time. I'm running it in GDScript and it's not even noticeable in the debugger. So first, let's look at the fake version. This smoothing is taking the current velocity and trying to bring it to 0. So each frame, I divide the velocity of my camera by some number. And you can imagine that if my velocity was, for example, 10, which is an arbitrary number, to begin, then the next frame it's going to be 5, and then the next frame it's going to be 2.5, and the next frame 1.25, and so on. And so I'm always going to slow down by a certain amount, and it's going to never quite reach 0. And you can do this for any number above 1, so it doesn't need to be divided by 2 every frame. It could be divided by 1.1 or 1.01. It would just take longer for it to slow down. Of course, dividing by 2 every frame means it's highly dependent on the frame rate. So what do you do? Well, of course, you're going to multiply your divider by the delta time. And here is the root of the problem. If your frame rate has big variation between each frame, for example, I don't know, you're debugging and you're running very, very slow, or you're trying to debug some kind of performance issue that's crushing your frame rate or something, then you will run into issues with this fake version. Which brings us to the second method. Because when you think about it, what does dividing by 2 every frame means? Well, if you plug it into Excel or something like that, it will tell you that this is basically just doing an approximation of the exponential function. And my second method is just basically using this exponential function and doing exactly the same thing as the method before it. But it takes into account what happens between, where the fake method, what it's basically doing is doing a linear interpolation between the previous frame and the next frame, following an approximate exponential curve, where using actual exponential, I know what point I'm on the curve at any point in time. Which means that this method can handle any kind of variation of the delta time without any issue whatsoever. Even if you're running at 5 FPS, even if you're running at 0.5 FPS because you're debugging step by step, for example, your game, it's never going to freak out on you. And to prove my point even more, let me just run the game and show you exactly what I mean. First, let's just compare both methods at a regular FPS, around 30 FPS maybe. And if you look carefully, you shouldn't see much difference. I mean, I've tweaked the parameters so that they're as similar as possible as I can get them. And probably you won't see much difference when you're running at 30 FPS. But what happened if I drop the FPS to, admittedly something unreasonably low? So let's go into the project setting and set the FPS limiter in Godot to something really low. And let's look again at both methods. As you can see, in the real version, not much has changed. Of course, it's hard to tell that there's a slowdown going on because it's basically slowing down between both frames, but nothing weird is happening. It's still slowing down in maybe 1 or 2 frames, and it looks alright, albeit very chunky. But what happened to the fake version? I don't know if you can notice it on the screen right now, but sometimes it's gonna stop very quickly, sometimes you're gonna see it slowing down for a couple of frames, sometimes it's even going to bounce back and start going in the opposite direction. I even managed to get it kind of stuck in between two values where it's just bouncing back and forth forever. Yes, of course, you're never going to release a game with such a low FPS, but like I said, when you're trying to debug some issue and you end up with problems with your camera like that, it can be very annoying to go back to debug the original issue you were trying to work on. Look, if I go back and I set the FPS to even 1 FPS, then you're gonna see that the fake version is completely broken. Now, I'll admit that this might just be me suffering from some kind of traumatic experience. I think all programmers have things that triggers them that come from past mistakes or something like that. And in my case, it happened to me before, and I've had to deal too often with FPS dropping below 1 and the whole game breaking down for me to not care about these kind of behaviors at low FPS. I mean, who knows, someone might even want to run your game on a toaster, and he's gonna be so sad that he can't get it to work properly because of the camera. But that's why now I just take the time to properly implement an exponential function when I want to do some smoothing, even if it's a little bit more complicated and the mathematics require me to do some hardcore thinking. But in the end, the result is just better. I hope my explanation were clear. If you have any questions, comment, or suggestion, just leave a comment below this video, click the like button, subscribe, and I hope to see you guys soon, but maybe not next week because I'm still quite busy, but I'm doing my best to try to keep you guys updated with everything I'm working on. So see you guys in my next episode. Bye!